Hello children, welcome back to my channel. I am now dealing with 10th class mathematics similar triangles in that exercise 8.4. First problem is prove that sum of the squares of the rhombus is equal to sum of the squares of the diagonal. So let us first draw rhombus. A, B, C, D is the rhombus and AC and BD are the diagonals, they intersect at O. Very important one it is, children. Given, what is given? ABCD is a rhombus and AC and BD are diagonals. Now what is RTP? Sum of squares of sum of squares. Find the sum of squares of sides of rhombus. Squares of sides of rhombus, children. That means what is RTP? AB square plus BC square plus CD square plus DA square. These are all the sum of the squares of the sides of the rhombus is equal to what is that they are saying? Sum of the squares of the diagonals. That means AC square plus BD square. Here, what is the property that we are using, The property is diagonals of a rhombus are perpendicular bisectors. This is the property we are using. That means these two are equal, and this is perpendicular to each other. So, let us see the proof. Let us take first triangle AOD. In this triangle AOD, angle O is equal to 90 degrees. Therefore, AD square is equal to OA square plus OD square. Why is it 90 degrees, children? This is property of rhombus. Basing on that only we are saying angle O is 90 degrees. So actually what is OA, children? We have already done. Diagonals are perpendicular bisectors. They divide each one into two equal halves. So OA is nothing but AC by 2 whole square plus OD also is nothing but BD by 2 whole square. That means AC square by 4 plus BD square by 4. So if you take LCM 4, we will be writing AC square plus BD square. That means what are we getting? AD square is equal to AC square plus BD square by 4. What does this implies? This implies This implies 4 times of AD square is equal to AC square plus BD square. 4 times of AD square means what, children? AD is the side of a rhombus and we know that each and every side of a rhombus are equal. So we can write it. This implies AB square plus BC square plus CD square plus DA square is equal to AC square plus BD square. Hence proved. Very, very important theorem, children. Problem, children. Please note it down. Now this is second problem, children. ABC is a right angled triangle, right angled at B. D and E are any points on AB and BC. You have to prove that AE square is equal to AE square plus CD square is equal to AC square plus DE square. AC square plus DE square you need to prove. So what is given to us? In triangle ABC, angle B is equal to 90 degrees. D lies on AB and E lies on BC. What is RTP? You need to prove that AE square plus CD square is equal to AC square plus DE square. Now let us see the proof. AE square means you take triangle ABE. In this triangle ABE, angle B is 90 degrees. Therefore, AE square is equal to AB square plus BE square basing on Pythagorean theorem. Now, CD means you take triangle BCD. Angle B is equal to 90 degrees. This is given to us, children. Here also I have to write it is given to us. Therefore, CD square is equal to, what is CD square? BD square plus BC square. Now, this you consider it as first one, this as second one. You need to add them. First plus 2, that is AE square plus CD square is equal to AB square plus BE square plus BD square plus BC square. Now, let us group it. This is nothing but AB square plus BC square plus BE square plus BD square. I have grouped it like this. So, what is AB square plus BC square is nothing but AC square plus BE square plus BD square is nothing but DE square. Therefore, AE square plus CD square is equal to AC square plus DE square. This is the proof, children. This is second bit. Now third problem, children. Third problem is prove that 3 times the square of any side of equilateral triangle is equal to 4 times the square of its altitude. So let us first draw an equilateral triangle. ABC is an equilateral triangle. Now you have to draw an altitude. AD is an altitude. This is given to us. So what is given to us? In triangle ABC, AB is equal to BC is equal to CA, equilateral triangle, and AD is perpendicular to BC. This is the altitude. Now what is RTP required to prove? Prove that 3 times the square of any side of a triangle. That means let me take AB. 3 times the square of any side of an equilateral triangle is equal to 4 times the square of altitude. So here, what is the property that we use here is, for an equilateral triangle, for an equilateral triangle, median and altitudes are one and the same. What do you mean by this? Not only AD is perpendicular, AD bisects BC. BD and DC are equal. This is why, because of an equilateral triangle. That is why it is mentioned that it is an equilateral triangle. So let us see the proof. For the proof, let me take triangle ABD. In triangle ABD, angle D is 90 degrees because it is given to us. Therefore, AB square is equal to AD square plus BD square basing on Pythagorean theorem. That means this is AD square plus BC by 2 whole square. Because I said here, median and altitudes are one and the same. So D is not only the altitude, AD is not only the altitude, AD becomes the median also. When AD becomes the median, it divides BC into 2 equal halves. So it is AD square plus BC square by 4. Means take LCM, 4 AD square plus 4 AD square plus BD square I'll get. This can also be written as 4 AD square plus AB square by 4. Why am I writing it? Because BD is equal to AB. Equilateral triangle they said no. So what am I getting here, children? What I got? AB square is equal to 4AD square, 4AD square plus AB square by 4. So here I am sending it here. 4AB square is equal to 4AD square plus AB square. That means 4AB square minus AB square is equal to 4AD square. 4AB square minus AB square is 3AB square is equal to 4AD square. This is what we said, no? That we need to prove. We have proved it, children. This is the proof of the third one. So please note it down. Now, fourth problem, children. PQR is a triangle, right angled at P. So, let me draw PQR, PQR, right angled at P. M is a point on QR. So, let me write MB is a point on QR such that PM is perpendicular to QR. So, show that PM square is equal to QM into MR. So, what is given to us? In triangle PQR, angle P is equal to 90 degrees. PM is perpendicular to QR. What is RTP? What we need to prove? PM square is equal to QM into MR. What does this imply, children? PM into PM is equal to QM into MR. This implies PM by QM is equal to MR by PM. Why am I writing this? With this, you will understand what are the sides of the triangle which are dealing with, so that we will understand what are the two triangles that have to be proved as similar. So PM by QM is this. That means I should talk about this PQM triangle. MR by PM is this triangle MRP. So I need to prove that these two triangles are similar. Then I can say this. So let us see the proof. Proof is, we know that triangle PMQ is similar to triangle PQR, which you have learnt by a theorem. This is first one. Also, triangle PMR is similar to triangle PQR. This is also basing on the theorem which we have learnt. This is second one. From 1 and 2, we get triangle PMQ is similar to triangle PMR. Therefore, when they are similar, you can write this. That is, PM by QM is equal to MR by PM. What does this implies? PM square is equal to QM into MR. Hence, proved. A very simple one. This is possible only when you could do it, this children. Please write it down. This is fourth one. Now, fifth sum, children. They are given a figure like this. ABC is a right angle triangle, right angle at A. AC is perpendicular to BD. You have to show that AB square is equal to BC into BD. AC square is equal to BC into CD, DC. AD square is equal to BD into CD. So, what is given to us? In triangle ABC, angle A is equal to 90 degrees. AC is perpendicular to BD. What is RTP? First bit, AB square is equal to BC into BD. And second bit, AC square is equal to BC into DC. And third bit, AD square is equal to BD into CD. So let us go for the proof. First we will go for the first bit. AB square is equal to BC into BD. What does this imply, children? AB into AB is equal to BC into BD. What does this implies? AB by BC is equal to BD by AB. Earlier also we did this. How to do is, children, so that you will understand very clearly what are the two triangles which we need to similarize. So, AB by BC, AD by BD. That means what is that it is talking about? Or AB by BD we can take here. AB by BD, BC by AD. You can take. That means you need to find out BC by AB, children. It is BC by AB. Okay. Now, what is that we have to talk about? AB by BD. AB by BD means AB can be considered as the triangle. This triangle, BD is this big triangle. And also, BC is this triangle side, AB is the side of the big triangle. So, in triangle ABC and triangle ABD, ABC it is. Angle A is equal to angle C, 90 degrees. Angle A is equal to angle A common. Therefore, triangle ABC is similar to triangle ABD basing on angle corollary. So, what you can say? AB by BD is equal to BC by AB. What does this implies? AB square is equal to BD into BC. So, this is the proof of the first bit, hence proved. Now, let us go to the second bit. Second bit we have to talk about AC square is equal to BC into DC. That means AC into AC is equal to BC into DC. AC is this, and BC, this is AC, and BC and CD. That means you have got AC is the side of these two triangles, BC is the side of this triangle, and CD is the side of this triangle. So we need to prove that AC by BC is equal to DC by AC. You can prove it by taking triangle A in, we will be we can say that triangle ACRD. We have done it here, children. ABC, triangle ABC is similar to triangle ABD. We have just now proved. Similarly, triangle ACD is similar to triangle ABD. Even this also, these two are perpendicular, this is a common angle. So just if you write similarly, that's enough. Therefore, we can say that triangle ABC is similar to triangle ACD. Triangle ABC is similar to triangle ACD. That means what? AC by BC is equal to DC by AC. This implies AC square is equal to BC into DC. So this is the proof of the second one, children. Now go for the third bit. Third bit is AD square is equal to BD into CD. That means AD into AD is equal to BD into CD. That is AD by BD is equal to CD by AD. So AD by BD is equal to CD by AD. That means this triangle and original triangle. We have already said that triangle ACD is similar to triangle ABC. Earlier we have proved it. Therefore, AD by BD is equal to CD by BD, which implies AD square is equal to BD into CD. Hence, proved. So, this is the proof of fifth sum, children. Sixth sum, children. ABC is an isosceles triangle, right angled at C. So, you have got a right angled triangle. A, B, C, right angled at C. And here what they are saying, it is an isosceles triangle. That means AC and BC will be equal. So what is given to us? In triangle ABC, angle C is 90 degrees and AC is equal to BC. What is RTP? You have to prove that AB square is equal to 2AC square. So, let us see the proof here. In triangle ABC, angle C is 90 degrees. This is given to us. Therefore, AB square is equal to AC square plus CB square basing on Pythagorean theorem. This is nothing but AC square plus AC square. Why? Because AC is equal to BC. So, this is nothing but 2AC square. Therefore, AB square is equal to 2AC square is the proof of this problem. This is also very, very important to some children. Please note it down. This is sixth problem. Please note it down. This is seventh problem, children. O is any point interior to triangle ABC and 2 bits are given to you. Show that OA square plus OB square plus OC square minus OD square minus OA square minus OF square is AF square plus BD square plus CE square. First bit. Second bit, AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. So, what is given to us? In triangle ABC, O lies interior of triangle ABC, and then OD is perpendicular to BC, OE is perpendicular to AC, OF is perpendicular to AB. Now, what is RTP? First bit, OA square plus OB square plus OC square minus OD square minus DE square, OD square minus OE square, OE square minus OF square is equal to AF square plus BD square plus CE square. This is first bit. And second bit, AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. This you have to prove. Now let us see the proof. What is the first one? OA square plus OB square plus OC square minus OD square minus OE square minus OF square. Let us take LHS of this. OA square minus OA square, let us take OA square minus OF square is nothing but AF square. So let me take OA square minus OF square as one group and OB square minus OD square. OB square minus OD square as one group plus OC square minus OE square as one group. OC square minus OE square. So OE square minus OF square is AF square plus OB square minus OD square is BD square. BD square plus OC square minus OE square is equal to OC square. We have got OC square minus OE square is nothing but CE square. So this is RHS, no? So we will be saying that therefore this, if you take it as LHS, this becomes RHS. Therefore LHS is equal to RHS. So this is the proof for the first bit, children. Now let us see the proof of the second bit. Now second bit. What is the second bit LHS? LHS is AF square plus BD square plus CE square. What is AF square? AF square means OA square minus OF square. This implies OA square minus OF square plus BD square. OB square minus OB square minus OB square minus OD square plus CE square. CE square is nothing but OC square minus OE square. So what is meant by this? AF square is what, children? OA minus right side we have got AE square. AE square is nothing but, how can you get AE square? OA minus OE. So let me take OA square minus OE square as one group plus. Next at CD square. CD square means OC minus OD. So OC square minus OD square. Let me take these two as a group plus OB square minus OE square. OB square minus what is you have got OB square minus OF square. We have got OA minus OE I have taken here, OB minus OF square I have to take. So OA square minus OE square, OA square minus OE square is AE square plus OC square minus OD square. OC square, this is OC square minus OD square is nothing but CD square plus OB square minus OF square is nothing but BF square. This is RHS. Therefore, LHS is equal to RHS. So we could prove both the ones in this way, children. Please note it down. With this, I am concluding my topic. Next part, I will do it in the next